This case is the linear regression with the trend and seasonality. So we can bring the new data here and then creating a time series data using start. Why we start 1978 year, and also number two is actually the frequency is 12. So I wanna explain this option here, the TS option. Starting is the 1978, and then second one. So our data is if this is a year, then you don't have to have anything. But 1978, and then I'm using second thing. That's the starting point. And then frequency is a 12, which means is what? Every year you have a 12 time point. What would be? That's a month. So what is the second one here? So frequency is 12 means your data is the every month's data, and the first data is 1978 second month, which is the February. So this is the starting point. You can specify what I have is the 1978 second month, and then frequency is a 12, which means it's a monthly data. I have a 12 months, and then on a new year coming in, and so on. So you do the dynamic linear model, and then log is just log, so don't worry about the log here. And then we trying to run the regression using this data, and here as the independent variable, I can type in the trend and the season. This should not be here. Yeah, and the season. And the data set is a TS data because I created a TS data here. This is a pretty common what we use, but why I'm using the dynamic linear model, because I want to use a trend and the season here. Okay, so if you run this one, trend will be a trend here. Trend will be just trend, right? But season will be something like this. It's a February, March, April, May. But if you take a look at this data, as you can see, we have a February, March, April, May, June. But why we don't have a January? You know, when we have the multiple, this is a dummy variable, right? Categorical variable, we should get rid of at least one variable. Do you remember? If we have like a 4, then we have to drop 1. When we have a 2, we have to drop 1. So when we have a 12, you should drop 1. In our case, we dropped the January. So don't we? So which means we don't have a January data at all? No, actually we have a January data. This is our January data. What is that? So it's not February, it's not March, this is not April, this is not May. We don't have a 1 at all, right? This is not June, not July, not August, not September, not October, not November, not December. So what could it be? This is a January. This is January data. So the intercept actually contains the January portion. So when there is some dummy variable has a 1, then that the coefficient is the effect of the August effect or July effect. But since we don't have a January, our intercept contains the January effect. So we clearly has a January data, but we don't have a independent variable for the January, because once you have it, and then our computer has a big trouble to find out the intercept, because there is no data point that has everything is 0, right? If we include here the January here, then we will have a 1 in January, so which means there is no data point, every dummy variable is 0. So then the computer will have a big trouble to find the intercept. That's why we have to drop at least one of them. Okay. That's why we don't have to create the seasonal, but actually it's automatically find out the seasonal part. I don't have to type in the like February plus, March plus, and so on. And trend is the same as we include like years. So you can have a like a year. Right? We should have a year. Where is the? It doesn't have a year. We have a T here. We don't have a year. That's why we have to specify the first one. Our first data is the February and 1978, right? And then every 12 data, so 1 year passed. Okay, so that's why we have to specify the here we specify our first data is the when, and then every 12 years is a 1 year goes up, and so on. So trend is the when we use the year as our independent variable, what would be our coefficient? Okay, to see the trend, actually what this trend is doing, we can do the two things. The first thing is just using the linear model. We are just making a run a regression using the T. T is the here. This is 1, 2, 3, 4, 5. Actually, this is a month. So we can run the regression here. Then you can see the T has a coefficient and then intercept here. And also, we're gonna run the dynamic linear model, and then using only the trend as the independent variable. And then if you run, then what you're gonna see is the coefficient is a 12,988. Intercept is 5.46. So if you compare, intercept is the same, 5.46028. 5.46028, but actually this number is different. The reason is that this T is the every month step, but here the trend is the year, because we set the TS data is the frequency is the 12. So actually this one, the trend is calculated by the year. 1 year is 12,988. But this one is a 1 month data. So let's check it. Is it same? So I will type in the 88 here, and then you just run it, and then you can find out this is a 0.0108, which is the same as this number, 0.01082. This is a 0.01082. So you can tell what is the trend is doing here. Actually, it's the same as though we run the regression with the time. Yeah, only difference is that this T is just 1 month. This trend is the 1 year. The trend is not always a year, because when we created our TS, we set it up. This is a year, and then everything frequency is 12. So actually our data time is increased by 1 every 12 data point passed. In that, because we defined our data in that way, that's why this trend is the 1 year here. Okay. Now, of course, the coefficient is different here because now this model has a lot of different factors there, so the coefficient is different. But to compare what's going on in the more intuitively, we want to find out. that's the same as this one, dynamic. And then if you just put the trend, then actually it's the same as you regress with a year, even though our data set doesn't have a year here. We don't have a, we generated a year here. No, this one. This is different time data. We don't have a year, right? We have only time t 1, 2, 3, 4, 5, but it generated a year. We can find. Okay, so that's it for our R here.